So here I've drawn the five limits that we were looking at. So the first one was x over log x as x goes to infinity. And you can see that as I zoom out here, okay, this x, although it's growing slowly to infinity, it's going to go to infinity, okay, because we have a strong function over a weak function here. So if we flip it around and do the opposite, okay, so turn that off, notice that, yeah, this one here, it starts off going up, but then eventually it's going to start going down, okay? And it does it slowly because x is not that strong, but log x is even weaker. And what ends up happening is it starts tending to go back down to 0 again. Okay, so that one is a weak over strong, and it's going to go to 0. So if we take a look at this one is sine x is going to go to a maximum of 1 and a minimum of negative 1. And it's over log x, which is a weak function. But notice as we go to infinity, although it's going to bounce up and down between 1 and negative 1, eventually what's going to end up happening is that this graph is just going to tend towards 0. Okay, so never going to, although it's going between negative and positive, it's going to tend towards 0. Now it does it very slowly because log x is weak. But again, it doesn't matter. Log x has the power of infinity behind it. So eventually it'll go to infinity, albeit slowly. It'll eventually get there, and it's going to give us a 1 divided by infinity situation. So this one here, the numerator is a very strong polynomial. So you can see that this function grows very quickly. But again, e to the x has the power of infinity behind it. So although the base here is going to be infinity, here the power is going to go towards infinity, and the power is more powerful, has more of effect. So as I zoom out, eventually what happens is you can see that graph starts coming down because of the power of the denominator starts to take over, and it looks like it tends towards 0, and it does. Okay, because the numerator, or the denominator, eventually outpowers the numerator. Okay, this power 23, it doesn't matter. This x e to the power 100 is going to dominate this power 23. So we have a weak over strong. It says this, although this is strong on top, this is even stronger on bottom. So that it tends back down to 0. So here we have a weak over weak, but this is really weak. The log is really weak, and the 15th root is just moderately weak. So when we graph this, okay, what it looks like is this. So it's going up, okay, that log function, doing its thing. But as we start zooming out, okay, eventually, it's kind of hard to see, okay, but maybe I'll just change the settings here. Okay, so I'm going to let the x-axis go out to, 10,000. Okay, and I'll just make the y-axis so we can see it a little bit better. Okay, so if we zoom out, we can see that the graph does tend towards, so maybe I zoomed out a little too much. Okay, there it is. Okay, so eventually this graph is going to eventually come down. Now, it takes a long time, so I'm going to have to play around with this. So I'm going to have to make the x like really, really big. Okay, so notice as I add the zeros, it starts to come down. It does eventually, although it takes a long time because the log function, this denominator is a very weak function. Okay, and the log function is always growing. As I add more zeros, you can see that eventually it takes a long time. So look at the powers here. This is 5 to the 10 to the power 53, but eventually, okay, this does tend down to 0. Okay, so there it is. We have the nice thing about these endpoint behavior ones is that we have the power of infinity behind us, and we can eventually, as long as the functions are more powerful, one will dominate the other.